Okay, so let us just start with creation of data, how to generate the data set. See, the researcher James, he has not provided the data set that we used for training an algorithm, which is we had one Excel sheet in which first column was the some input, second column was some other input, and it was very easy to directly upload the file, then divided it into train set and test set, etc. However, they have given EEG signal of each patient. Okay, so this is the EEG signal of first patient. So the file name is 507 depression underscore rest dot mat. If you see here carefully, it is not dot CSV file, it is dot mat file, which is dot matlab file. It will be very difficult to directly upload this dot mat file. So we have to convert this dot mat file into dot CSV file first. So our first step is conversion of all these dot mat file into dot CSV file of a signal. Okay. So this complete data is available on this particular website whose link I will put in the group. What you need to do is you need to download this complete file. Firstly, you need to download all this complete file. This file is of 6.68 GB. So your computer should be having enough space for that. As you can see, each uh, uh, EEG signal is of 57.8 MB. Okay. For example, you converted this .mat file into .csv file. So if I converted this first file, I'm having on my desktop, I guess. So after conversion, it will look somewhat, oh, it's not there. Okay. Okay. So let me just convert this .mat file into .csv, then we will see. Okay. So um, I have found one code from internet which converts your .csv, your .mat file into your .csv file. So initially the same work was done by one of our student Nihal, and he converted each and every file manually for by a single code. But I have found a code in which you will just write the name of folder in which 60 70 .mat files are available. A new folder will be created which will convert all the .mat file into all the .csv file. So it becomes very easy. Okay. The only thing that I need to do over here is this much code when you wrote, you just need to write the path of the folder which contains .mat file. I repeat again, you need to write over here the path of a folder which contains .mat file. So here they are saying mat underscore file is equal to something something. Then this is the path of that file. Okay, same goes over here. Mat underscore file path same. The file which contains .mat need to be written over here. So I'm going on my desktop, and I have kept only one .mat file over here, as you can see, because when I downloaded it, it was 6.68 GB on my desktop, and I was finding it very difficult to run my other codes. So for now, I'm keeping only one file over here. So let me go back, and here I am just copy pasting the path. So copy as path. Then I'm going back over here, and when I paste, this R should be written, otherwise it will give you error. Same thing is there. I've already done it. After pasting your path of the folder which contains .mat file at two particular positions, at there and at particular over here, then you need to put the path of the folder in which you want your .csv file to be saved. So I want my .csv file to be saved in mddd csv folder. Here I have created three more folders. and here in original part, okay, it was there in original part. So in original part, I want to save it like this way. Okay, so what I'll do is I'll go in this original and then let me just copy the path. Already I have done it once, but let me do it again. Okay, and then I will paste it. I think the same location is there. I have not changed anything. So let me just run this program. See, after running, no, it will find whether any .csv file is there or not, any EEG signal is there or not in a particular .mat file. So all these things will be there. If nothing, no error is there in the system, let me just come downwards. Okay, there is no error in the system, so it will just show you that these many channels are available. As you can see, FP1, FPZ. So this particular signal, no, EEG signal is having 64 channels. The signal that we saw for ADHD, it had I think 19 channels, but here they have used 64 channels. So they have made it more complex. Okay. So let us just check in that folder whether it is saved or not. So I'm going in this original folder. So since it was already there, let me just refresh it. Okay, it was already there in the folder. So I think let me delete it and let me just run it again. Let me see whether it is working or not. So maybe it was already there, because of which let me just shift and run. Okay, so did it save? Okay, let me check. See now. I had deleted it. See you 20.03 8 बज के 3 minute. So now it has saved. So this is the .csv file of EEG signal, converted from .mat file. Now you can open it. God, it is taking time. It will respond. It is just taking time. See. So there are 64 channels from FP1, FPZ, and these are the signals. So this is the first electrode of first patient. Please understand, ये पहले वाले patient, patient number 507 is the first patient in that list. उसके सर पे 64 electrodes लगाए गए हैं, 64 electrodes. Every electrode is giving a signal, and signal is represented in the form of data points. This we have already discussed. अगर मुझे ये सिग्नल प्लॉट करना है, तो आई एम जस्ट फॉर फर्स्ट इलेक्ट्रोड, लेट मी गो इन इंसर्ट एंड लेट मी प्लॉट अ ग्राफ. नाउ you will understand that this is a signal. So once I am plotting a graph, so signal is looking somewhat like this. But according to my judgment, what is happening is the EEG signal uh, is there till this 24,000 data set, and after that it is giving some shabby part. So what I want is ये जो हर एक जो सिग्नल है इसमें से सिर्फ 10 या 15,000 डेटा सेट ही यूज करे. 15,000 मतलब जैसे ये फर्स्ट है, सेकेंड, थर्ड, फोर्थ, फिफ्थ, सिक्स, सेवन. सो दीज आर 7 डेटा पॉइंट्स. ऐसे ही सिर्फ 15,000 डेटा पॉइंट अगर हम लोग यूज करेंगे स्टार्टिंग के, तो हमें एक अच्छा सिग्नल दिखाई देगा. क्योंकि ये बहुत सारा डेटा सेट है ना, हेंस वी कैन नॉट सी द सिग्नल प्रॉपरली इन एक्सेल. 24,000 के ऊपर का डेटा सेट है. ठीक है. सो यहाँ 24,000 के आगे शैबी हो गया है. सो बीइंग ऑन द सेफर साइड वी विल यूज 15,000 डेटा सेट. यहाँ तक जहाँ पे मेरा अभी कर्सर है वहां तक हम यूज करेंगे. तो अभी और डिलीट करना होगा, तो हम मैनुअली डिलीट नहीं करने वाले. इफ वी गो टू डिलीट इट मैनुअली, इट विल टेक अ लॉट ऑफ टाइम. ठीक है. तो अभी तो .csv फाइल कन्वर्ट हो गया. I will not save it. So it is there in this original folder. When you convert your .mat file into .csv file, what will happen is you will be having more than 70 .csv file over here. Because originally in my folder only one .mat file was there, so only one is getting converted. Now, as we had discussed that in the particular signal, original signal, hence I have made the folder because it is original signal. I want only 15,000 data points. Only 15,000 data points. So what I'll do is for that, uh, I think I had one code. Okay. Then what I did, import pandas as PD. Then df is the name of data frame. And then I have just uploaded. For now, I am putting this thing as hash. Okay. So this is your EEG signal. Okay. And the number of rows are 250734, 25,000. As you can see carefully, why I am taking only 15,000 data from the top, because as you can see, the last ones are zeros and abnormal numbers, which will give you faulty calculations, faulty values of your features. So being on the safer side, I am taking only first 15,000 data for every CSV file, only 15,000 data. For that, what I will do is, this is df is my data frame. Then I am creating a new data frame F507. Always uh, keep in mind about always give a proper name to your data frame. So my new data frame is name is F507 because the name of the patient was F507. df dot drop. What I am dropping? I need to drop the values from 15,000 to 250734. Why 250734? Okay, so I'm dropping this much of data. So let me just do F507. See, 14,999, 15,000 rows are there. Okay, now you can see even now the somewhat values are getting very lower over here. It is in 300 and it is in 0.62, 0.41 somewhat. But in other columns, if you see here it is 18, here it is 30, 28, 83. So somewhat I am feeling that 15,000 data will be okay. Okay, we have kept only 15,000 data. Now this data frame I am converting into .csv file again. So original .csv file was for 24,000 data. My new .csv file that I will be actually using for analysis is only for 15,000 data. Okay, I am storing it in what folder? Truncated folder. I have truncated means I have reduced it. So as you know, I had created one more folder over here which is truncated. That was original signal. This is truncated. Then again, the path of that truncated folder I have written over here. And the name of file, you please understand, the path is only this much. See, the path is only this much, truncated, till only this much the path is there. After that, I'm giving a slash and then I'm writing the name of file that I want. So the name of file that I want is 507.csv. This is the name of file that I want. Then you run it. So after running it, there will be a folder over here. There will be a file in this truncated part, 507.csv. Now when you open it, you will find only 15,000 data. Okay, let me just scroll downwards. So you will find, see, 15,001 because at the first row, there was name of the column. Okay. Now if I want to plot one signal of first electrode, let me just plot. And this is that signal. Now you can see somewhat EEG signal. Okay, now you can see the EEG signal, a part of EEG signal. Fine. So this is how we converted our .mat file into original .csv. From that original .csv, then we truncated to 15,000 data points. And this is how we have got our truncated one. Once you have received this, once you have received this, again we are coming over here. The next part is you need to calculate the features of this signal. See, all these things I had already explained in past, so I will not get into detail. What do I want actually? What do I want? I want a data sheet like this. I repeat again. I want a data sheet like this. If you remember carefully, some 1.5 month or 2 month back, I had told you guys to at least write the names of features of an EEG signal. And I had created one a Google form where students were writing it. We couldn't write everything, but we wrote something. Okay, so this is my patient number one, which is 507. The number is 507 for patient number one. And patient number one is having 64 electrodes on his head. So this is the first electrode. If you can see carefully, first electrode. Actually, our first electrode was what? If I go in this truncated one, what is our first electrode? The name of first electrode is FP1. FP1. So what we are doing is we will calculate the RMS value of this FP1 for first patient. So 507 is the first patient. How do you calculate RMS? Root mean square value. Or one of the feature is mean value. How to calculate mean value? You add up all these values divided by 15,000. That is mean value. Okay, similarly, there is another feature which is RMS value. So what I have done is how my data set will be there. My data set, my first patient, and the first electrode ka feature P2P. P2P means peak value. Peak to peak value is one of the feature. Like mean is one of the feature. RMS is one of the features. Similarly, P2P is one of the feature. Okay. So P2P I have calculated and I have got 579.05. Okay. For my first patient. Similarly, you need to calculate RMS of the first electrode of first patient. First electrode, first patient means this is first patient 507. First electrode is FP1. If I zoom in, you see carefully. This is first electrode FP1. FP1 is the first electrode. First electrode ka P2P. Then first electrode ka RMS. Then first electrode ka activity is one of the feature. Okay. Then first electrode ka mobility is another feature. Then first electrode ka complexity. So complexity is one of the feature. First electrode ka Shannon entropy. Then first electrode ka kurtosis. So all this thing is first electrode ke features. First electrode ke features. Okay. And I have calculated for now P2P. Similarly, you have to move on second electrode. See, this is the second electrode. FPZ was the second electrode. If you see here, FPZ is the second electrode. Okay, if it is second electrode, तो second electrode का first feature actually यहाँ पे P2P होना चाहिए. हाँ, यहाँ पे P2P. I should not be marked. It should not be marked in yellow color. So इसको blue कर देते हैं. Okay, so this is second electrode का पहला feature. And then second electrode का दूसरा feature is again RMS. Second electrode का तीसरा feature is activity, mobility, complexity, Shannon entropy. You see over here, huh? You see over here. Then kurtosis. तो इस तरीके से सिर्फ दो इलेक्ट्रोड्स के फीचर्स लिखे हुए हैं. यू नीड टू राइट फॉर 64 इलेक्ट्रोड्स. हर एक इलेक्ट्रोड, हर पेशेंट के हर एक इलेक्ट्रोड के 7 से 8 फीचर्स हमें लिखने हैं कम से कम. So see how many number of inputs will be there? Many number will be there. So 64 into how many feature? 1, 2, 3, 4, 5, 6, 7. 7 into 64. That much amount of inputs you will be having. Okay, since the number of input has increased, we will apply principal component analysis. This is how we will be revising our first part. Okay, how did I get the value 579.05? I haven't done it manually. Okay, what I have done is I have written a code. See over here. Firstly, let us see for RMS. Okay, you will find such codes on internet for Shannon entropy, for kurtosis. Okay, so it doesn't matter from where you get the code. For now, time being, you search for the codes and you get the values converted. So imported numpy as np, created a function. Name of function is calculate underscore RMS, and then I have written F507. Okay. F507. So I am sending the complete .csv file whose name is F507 into this function. Then I have written, you can see the, अभी सब कुछ एक्सप्लेन करना इज डिफिकल्ट. यहाँ पे एक फॉर लूप लगा के फिर एक रिजल्ट जो है, रिजल्ट को वापस से रिटर्न किया गया है. तो यहाँ पे जब मैंने प्रिंट किया, आफ्टर प्रिंटिंग यू कैन सी दीज आर दी आरएमएस वैल्यू. ये सब उसके आरएमएस वैल्यूज है, किसके, पहले पेशेंट के आरएमएस वैल्यूज है. ठीक है. एंड इफ यू कैन सी, तो मैंने यहाँ पे लिखा हुआ है एनपी राउंड. व्हाई आई हैव रिटन एनपी राउंड? बिकॉज इफ आई रिमूव दिस एनपी राउंड, you will be getting a very big number. 84.256789 something very big number was there. So np राउंड करने के बाद यहाँ पे जो भी लिखोगे, वो एक एरे है numpy का, उसके बाद 2 डेसिमल तक इसको राउंड किया गया है. ठीक है. और ये फॉर्मूला है फॉर आरएमएस वैल्यू. यहाँ पे एक फॉर लूप लगाया गया है फॉर कॉलम इन, सो दैट वो हर एक कॉलम के ऊपर जाके वो हर एक कॉलम का आरएमएस निकाल सके. ठीक है. वो रिजल्ट में स्टोर करके फिर अपेंड किया गया है. सो दैट यू नीड टू सी केयरफुली. दिस पार्ट आई विल नॉट एक्सप्लेन इन डिटेल. हाँ चलो, ये आरएमएस वैल्यू ऐसे निकाल दिया. सिमिलरली पीक टू पीक के लिए भी वैसे ही एक फंक्शन है, कैलकुलेट अंडरस्कोर पीक टू पीक, फिर उसमें भी 507 डाला है, यहाँ पे राउंड अप कर दिया है. अब देखो क्या किया हुआ है राउंड अप करने के बाद. सी केयरफुली. यहाँ पे जब राउंड अप कर दिया है ना, तो आई एम गेटिंग अ नंपाई एरे. ठीक है. यहाँ पे राउंड करने के बाद एक नंपाई एरे मिल रहा है, तो ये वाला है वो नंपाई एरे. सो दिस इज दैट नंपाई एरे. ये वाला, ये किसका है? ये इस प्रिंट कमांड का है. यू कैन सी ओवर हियर फॉर दिस प्रिंट कमांड. ठीक है. उसके बाद क्या किया है, इस नंपाई एरे को डेटा फ्रेम में वी हैव कन्वर्टेड. ठीक है. तो P2P डेटा फ्रेम में कन्वर्ट नहीं किया है, उसके बाद इसका ट्रांसपोज ले लिया है. सॉरी सॉरी, डेटा फ्रेम में कन्वर्ट किया है. यहाँ पे डेटा फ्रेम में जब आप कन्वर्ट करोगे किसी भी चीज को, तो डेटा फ्रेम में कन्वर्ट करने के बाद वो एक कॉलम में आएगा. हमें कॉलम में नहीं चाहिए, हमें कॉलम में नहीं चाहिए. लेट मी जस्ट शो यू. यहाँ पे प्रिंट P2P P2P अंडरस्कोर 507 अंडरस्कोर 507. सी ओवर हियर एक कॉलम में आ रहा है वो डेटा फ्रेम, पर मुझे ऐसा कॉलम में नहीं चाहिए. ये पीक टू पीक की वैल्यू है 579 488 428 507. कॉलम में नहीं चाहिए. मुझे कैसा चाहिए? मुझे चाहिए पेशेंट नंबर 1 का FP1 इलेक्ट्रोड का पीक क्या है? 579. FP2 FPZ का क्या है? 487. तो जैसा वहां दिख रहा है एक्सेल शीट में, वैसे ही यहां पर भी दिखना चाहिए. सो व्हाट आई हैव डन इज आई हैव मेड अ ट्रांसपोज. यहाँ पे मैंने ट्रांसपोज कर दिया. ट्रांसपोज मतलब कॉलम को रो में कन्वर्ट कर दिया. रो में कन्वर्ट करने के बाद में इस कॉलम को नाम दिया है ए. P2P अंडरस्कोर F07 डॉट कॉलम्स, मतलब उसके कॉलम को कुछ नाम देना पड़ेगा ना. वो नाम है ए. और ए कहाँ से आया? ए ए ए ए समवेयर ओवर हियर, जिसको मैंने हैश कर दिया था. तो ए इज डीएफ डॉट कॉलम्स. तो इस डेटा फ्रेम के कॉलम का जो नाम है, उसको मैंने ए नाम के एरे में स्टोर कर लिया. ठीक है. वो स्टोर करने के बाद P2P अंडरस्कोर 507 डॉट कॉलम्स में मैंने उसको डाल दिया यहाँ पे। ठीक है, फिर ये जब मैं रन करूंगा, विल इट शो एनी एरर टू मी? नो। अब देखो यहाँ पे क्या होता है, FP1 FPZ, अब ये नाम आ गया यहाँ पे पूरा। ठीक है, ये होने के बाद फिर से P2P_507 को CSV में कन्वर्ट किया और उसको रफ फीचर नाम के इसमें मैंने स्टोर कर दिया। तो रफ फीचर नाम का जो फोल्डर है उसमें मैंने इसको सेव कर दिया, एस यू कैन सी ओवर हियर। तो हमें पीक टू पीक वैल्यू मिल गया। तो आपको पहले कैसे मिल रहा था, यहाँ पे सारे नंबर्स थे, वो सारे नंबर्स कन्वर्ट हो गए, पीक टू पीक मिल गया है। जैसे यहाँ पे बहुत सारे नंबर है और आपको जो डॉट CSV फाइल मिल रहा है वो मिल रहा है RMS वैल्यू या मीन वैल्यू, तो आपको ऐसे अरेंज करके मिल जाएगा ये वाला। सो नाउ व्हाट आई हैव डन इज, मैंने नंबर यहां से उठाया है, कॉपी किया है, फर्स्ट पेशेंट का फर्स्ट इलेक्ट्रोड पीक टू पीक, फर्स्ट पेशेंट का फर्स्ट इलेक्ट्रोड पीक टू पीक मैंने यहाँ पे पेस्ट कर दिया है। ऐसे ही मैंने एक सेकेंड इलेक्ट्रोड, मैंने पीक टू पीक सेकेंड इलेक्ट्रोड का भी है, पीक टू पीक सेकेंड इलेक्ट्रोड का 428। तो यहाँ पे सी वेर इट वेंट, हियर सेकेंड इलेक्ट्रोड का 428, ऐसे ही थर्ड का पीक टू पीक, AF3 का पीक टू पीक, ऐसे करते करते 64 के पीक टू पीक आपको लिखने हैं। यू प्लीज रिमेंबर वन थिंग, देर आर 64 इलेक्ट्रोड्स। हाँ, इसके अंदर ये HOG और VOG हम कंसिडर नहीं करेंगे, इलेक्ट्रोड्स में हम उसको काउंट नहीं करेंगे। ऐसे देखा जाए तो 66 कॉलम्स आता है, हम आखिरी के दो निकाल लेंगे। ठीक है, दिस इज हाउ। तो जैसे मैंने वो किया हुआ है ना फॉर RMS वैल्यू, सॉरी पीक टू पीक के लिए जो मैंने ये कोड्स लिखे हुए हैं, सेम कोड्स आप उठाएं, ये तीन चार कोड जो उठाए और उसको उठा के RMS में कर दो, तो आपको सीधा डॉट CSV फाइल मिलेगा वहां पे। ठीक है, RMS के लिए भी करो, जो जो आपको मिलते जाएगा कोड वो सबको डॉट CSV में आप ये 3 से 4 कोड्स आप लिखोगे तो आपको डायरेक्टली एक्सेल शीट्स मिलेंगे। तो ये 4 कोड इज वेरी इंपॉर्टेंट, यहां से लेके यहां तक डेटा फ्रेम में कन्वर्ट करने के बाद। ठीक है, एंड एट द एंड ऑफ द डे ये पूरा जो है डेटा सेट फिल हो जाना चाहिए। तो ये 2 कलर दिख रहे हैं, ऐसे 64 कलर्स आएंगे वहां